Hey everyone, Radhe Radhe. My name is Ayan Pasha. I'm the Cloud Native Developer Advocate, and today we'll be having a podcast where we'll try to learn about the Kepler. Kepler is a CNCF project. We'll try to dive deeper into the whole cutting edge solutions as well as also the cloud efficiency and the sustainability efforts that has been taken place by the Kepler. It's a project that is making a lot of contributions towards the sustainability as well as also cutting the cloud costs and reducing the extreme overhead computational power that has been wasted in the whole the cloud operations as well as also the production level operations that has been taking place at the moment, while diving deeper into the kernel at the kernel level. And it's unique matrices while using the Prometheus has been solving a lot of solutions and solving a lot of problems, and that's what we'll try to figure out. And with the help of an amazing contributor of Kepler. So yeah, let's get started. Hey everyone, my name is Ayan Pasha. I'm the Cloud Native Developer Advocate. Today we are having a really amazing
Mhm.
topic, a really amazing project that's Kepler. Kepler has been
Mhm.
contributing towards the monitoring as well as towards the observability stack. In the world where the data centers have been, bleeding a lot of power consumption as well as also monitoring has been ignored a lot in the whole world. Kepler has been coming up with an idea of using as a Kubernetes-based efficient power level exporter. Earlier, they used to use the eBPF as well as CDM and a lot of other things, but till now, they've came up with a new
Right.
exporter, and that's an amazing update as well to be kept in forward for the whole community. So yeah, we would love to know about your thoughts as well as also the update of the whole Kepler community. Here we have Vimal, who is one of the amazing contributor in the whole Kepler project. We would love to know about you as well towards your contributions, and yeah, we'll try to take some questions as well.
Yeah, I am Vimal. I'm with RedHat. So we joined Kepler Community Project and also Intel. So those are like three main contributors. Um, as you know, like initially, Kepler architecture was using very low level metrics from the OS. It uses eBPF to know about basically. Let me first tell you about like what the purpose of Kepler. Kepler's purpose is to it's a power metric exporter. So basically you deploy workloads in Kubernetes, like some maybe using CPU a lot, memory a lot, also GPU a lot. They consume a lot of powers. We can know the power usage across a rack or a machine using external power meters, but we don't have insight into how much my workload is consuming, or how much my set of workloads total is consuming. You may have some workload which are having different business aspect than some things will maybe not that important, but maybe consuming a lot of memory. So yeah, so um, we should know about it. We can compare and all those things. So that is the purpose. So Kepler produces, power metrics to tell you like how much power your process is consuming. It has various aggregation levels. You can know at highest level because it's in Kubernetes at a namespace level. Basically, you can say start from container level, then you aggregate by container to pod, and then pod to namespace. So you can know power level at various levels. So that is the aim of the project. Initially, if you know the name, it's a Kubernetes-based efficient power exporter, a Prometheus exporter, which exports metrics about power used by workloads. Okay, so in Kubernetes, it provides various levels of metrics. So you have node level power, so it can tell you overall how much power your node is consuming and how much power. Then you go further. If you enable process level metrics, it will tell you each process how much power it is consuming. Then you can aggregate those processes, because those processes, if they belong to a container, you can know like, yes, how much power my container is consuming. The next level, aggregate containers into pods, and then pods into namespaces. So you can know from its various levels how much power has been being consumed. So you can compare your different set of workloads in a one namespace, maybe more business relevant. So you want to maybe let it continue and then maybe stop another one, or you want to schedule a set of workloads to some other host, which is more efficient, or maybe it's in some other big data center or whatever. So you can, once you have the knowledge, you can maybe take more decisions on this. Okay. So how does basically Kepler uses various sensors from the host itself to know the power values. So one of the, so or as of now the only power source is RAPL, Intel RAPL. So Intel RAPL depending on the CPU, it provides different power zones. So you can know at the whole CPU package level, like all the cores, like there are 20 cores or 64 cores. At combine all that core, you can know core power. Okay, and combine core with DRAM and some other things, you have another power zone called package. And so it depends on the CPU. Different CPUs provide different power zones. Some maybe only provide DRAM and package, it does not provide core. So you have to do, you cannot know like in detail like how much the core power is. So Kepler uses RAPL, finds out what is available, and based on that, it will then try to allocate or attribute power usage based on the how much processes is using the CPU or RAM. Okay, so if process is using that's the main fundamental idea. If some process is using more CPU, we attribute more share of that power to that process. That's the whole basic, very simple algorithm. And so there's some concept like active energy, idle energy. So you can know more from the docs, but yes. So more a process is using actively the CPU, more energy contributions is allocated to it, and that's how it works.
That's awesome. So, in the past, many of the people, like me as well, as a newbie,
Mm.
who doesn't know as much about the whole thing and have just entered this whole stack, they just know about the OS and all those particular things, and the majorly upon the Kubernetes and a lot of networking stuff as well. So, they knew by Kepler used to integrate a lot along with the eBPF and the Selenium as well, and as you said, along with the BPF and from BCC and a lot of basic from starting in all of those particular components as well. It used to integrate along with all of them. And now a new exporter has been, written from the scratch by the Kepler community. So how does it make the difference? Like in the components, how does it make it more efficient or a lot more, helpful for the monitoring stack or anything else? So how is it a lot more beneficial as compared to the previous one? So and what were some of the reasons beyond switching off to this
Yeah,
particular
yeah.
new exporter.
Yeah, so when we started the Kepler initially was using eBPF. So the what is the main measurement Kepler wants to do for the process? Like how much time a process gets scheduled on the CPU. So that metric is called CPU time. So Kepler was using eBPF and using eBPF programs to just calculate if basically try in eBPF we can put trace points. So our particular trace point we were using was related to CPU scheduling. Whenever the process gets scheduled to a CPU, we will start a timer. Whenever the next one gets scheduled, we will calculate this PID consume this much nanoseconds or this much microseconds and all. So BPF layer will just calculate that, and based on that data we will take it to the upper layer, application layer in the Go code, and then just correlate it with this the RAPL data, power data, and divide. But problem with it's not, I won't say problem. um, I mean kept eBPF requires sudo access to,
Yeah.
or more you can say sysadmin capability access to access that. And earlier, this Kepler was also using something known as hardware matrix. So hardware counters, like how many instructions have been used, how many cycles have been used. So even very low level details we were capturing and using. But currently we are not using all that. We are using simply in the slash proc stack for each PID. We can also know um, from the file system interface itself, like how much each process is using CPU, user CPU, system CPU. So instead of going very low level, which requires more capability um, to use, so instead we just use what's already available from the file system. What it difference is, it requires right now for us to loop through the whole slash block file system, and then it requires a lot more syscalls. But yes, that's the but we don't need to, because this Kepler can run in VMs or maybe some environments where you don't want to give that lower level access to eBPF. Many customer telco operators, they are still wary of using eBPF. They see eBPF and it's not uh, they don't trust it, because if low level code can do anything, right? So, so maybe that was also, we got feedback. I think based on that feedback only, because CPU time we can know easily. If you can know, then why do go and that route? So that's the reason.
Yeah, that's awesome. Right. So also, as you told earlier, that the GPU you've been trying to explore about the GPU power monitoring of the NVIDIA, as well as also a lot of things that will
Yeah.
include the the future goals for the or the releases on which the Kepler team have been working fluently at the moment, have been since a while. So I was asking how important is the the GPU power monitoring for broader sustainability issues or for the AI ML workloads, and how Kepler team have been moving forward in this particular thing, towards its future goals of exploring more about the NVIDIA GPU power monitoring, or uh, yeah. So, what are
Right.
some of the
Right.
future goals or the releases on which the Kepler team have been working at the moment in the GPU power monitoring?
Right. So as of now, Kepler only can expose power from the CPU and whatever CPU zones is provided. Okay, but as world's moving more towards AI, more and more GPUs is getting used, and more power is also getting spent there. More power budget is getting spent there. So it's it's imperative that yes, Kepler should be able to monitor, basically able to provide metrics from the GPU workloads. So as of now, we are exploring like how NVIDIA's GPU exporter, and there's a project called DCGM. DCGM is a very low-level library, uh, which can and let you access and let you know like how much GPU memory is getting used, how much GPU, just like CPU utilization, you can know what GPU utilization, and you can also know from the power. And they also have a matrix exporter called DCGM exporter. So just as of now, trying to understand like how those components work, and their current dashboards provide. If we can, if you run a GPU workload, we can know the GPU power changing, and we can know like which workload is using the GPU as of now. But it has some limitations. We're exploring whether we should just use that uh, or directly, or just use the same matrix as exported, or you write our own exporter. So yeah, that analysis is going on right now, and not just for NVIDIA. We'll also aim for AMD, and we integrated GPUs. That's it.
Right. So also the KubeCon NA is just on the 9th of November, I guess. So is anyone going to be present there at the KubeCon NA from the Kepler team, if you guys know about it? Um,
I'm not very sure in the community, but yes, I mean, no one I know from Red Hat and in Kepler is going to be there, but maybe from community, some members may be joining. I can't comment like, uh,
That's awesome. That's awesome. All right. So yeah, if you does have anything to share from the open source, the open source experience at the Kepler community, it will be an amazing thing for the newbies as well who want to contribute towards this amazing project and to become a part of this initiative. So yeah, in how different ways they can contribute to the towards the making Kepler a lot more efficient towards the monitoring part and for the GPUs. Yeah,
Yeah, I'll say try to use it in various. As of now, we have tested mainly on OpenShift, which is Red Hat's. So try to use it in maybe like wherever wrapper is available, Kepler can be used. So we also have the upstream community operator and operator catalog there. We have upstream release as well as Red Hat releases. So it's be good to see Kepler being installed and used in, let's say, GCP or some other uh, place. As so that's one thing. Yes, use it and try to. Um, see we use on different kind of CPUs. Yes, about CPU, as of now, we're only supporting Intel, but yes, there are also plans for supporting ARM MPF. I think this support was also there in the previous Kepler, but because we rewrote everything, so some of that support was gone. So yes, we are bringing back ARM MPF processors and some maybe PowerPC or IBM processors as well if there is a need. So these areas are missing. So yes, contributions are welcome for this.
Yeah, that's awesome. Yeah, so yeah, thanks a lot, Vimal. Thanks a lot for the Kepler community as well. All the best to you as well as also to the whole community for this amazing initiative. We hope to see you again as well as also for the whole Kepler community at the KubeCon as well as also onto the other podcasts as well. I would love to see you again and get your more thoughts. And yeah, all the best for the the upcoming updates as well for the
Thank you.
community. Thanks a lot. Radhe.
Thank you.